Hi, in this video I'm looking at determining the confidence intervals, whether it's 95 or 90% for a standard normal variable or for a normal variable with mean 56 and a standard deviation at 15.7. So let's start off with part A. So for part A we've got a 95% confidence interval, and so that means that my confidence level, which is just C, is going to be 0.95. And to find our confidence interval, we need to know the proportion, which is given the letter alpha. And the proportion is given by the rule 0.5 plus or minus C on 2. And we can take either one of these limits, whether it's the upper limit or the lower limit. We'll just work with the upper limit. So we've got to have alpha equals 0.5 plus 0.95 over 2. And so now let's go and work that out. So I'm going to bring up a calculator. And so we've got 0.5 plus 0.95 over 2. And that gives us a proportion of 0.975. And so we want to use this proportion to give us our confidence interval. So we're going to go back to our calculator, go to the option menu, stat, distribution, normal, and get the inverse normal. And we're going to put in that proportion 0.975, comma, put in our standard deviation, which for a standard normal variable is 1, comma, and then put in our mean, and for a standard normal variable, that's 0. Press execute, and we have 1.95996. So we'll just put in 1.96. We'll round that 959 up to 96. So that's going to be our Z value. So that's our Z value, and because that's the upper limit, the lower limit would have been the same. It would be upper or lower. And so that's our answer. But our confidence interval, we can write saying the 95% confidence interval for the standard normal variable is about negative 1.96 up to positive 1.96. And that's all we have to write for that one, because we have a standard deviation of 1 and a mean of 0, so we're just going to go either side by that. So now let's have a look at part B. This time we want a 90% confidence interval, so C is going to be 0.9. And if we work out our upper limit, we're going to have 0.5 plus 0.9 divided by 2. And so if we work that out, put it into the calculator, 0.5 plus 0.9 over 2, we get 0.95. So now we've got to get our z-score. So we're going to go back to our calculator, and we're going to go to our stat, distribution, normal, inverse normal menu. We're going to put in our 0.95. I'm just going to put in the answer. And we're going to put in, because we've got a normal variable, we're just going to find this for the standard normal, and then we're going to adjust. So I'm going to put our standard normal in, and so we get 1.64485. So our z-score is going to be 1.64485. Yep. And so now we're going to work out, this is our upper limit on our z-score, we can work out our confidence interval. So our confidence interval is going to be given by our mean plus or minus our z-score times by our standard deviation. So for us, we've got our mean of 56 plus or minus our z-score of 1.644, we'll just put 9 for now, multiplied by our standard deviation of 15.7. And so if we go and work the confidence interval out by doing this, I'm going to get our answer, and I'm going to store it into Z as a decent enough variable, so that way we have it. And we're going to work out our interval. So we're going to have 56 plus our Z multiplied by our standard deviation, 15.7. Execute, and we have an upper limit of 81.82. And we'll go to 3 decimal places, 81.824. So that's our upper limit, 81.824. And we can get our lower limit by doing 56 minus our Z times by the 15.7, which gives us 30.17, and we'll round that to a 6. So 30.176. And so that's our confidence interval. Approximately, we've gone to 3 significant figures here because we're only approximations, so I've only gone to 3 decimal places, but that's going to be good enough. There is another way we can do this as well. Because we're using the inverse normal, I can actually put in my standard deviation and mean. So if I put in our proportion 0.95 and I put in our standard deviation of 15.7 and our mean of 56 and I press execute, I get 81.824, which is my upper limit. So I can actually use that to get my upper limit. So I get my upper to be 81.824, but to get my lower limit, that means that I've got to do some maths. And so if I think about what's going on, I've got my mean sitting in the middle of 56, and then my upper limit is 81.824, and I want to work out what this gap here is so I can subtract it off my mean of 56 and get whatever this number is. So my lower is going to be my mean minus off our upper limit, 81.824, minus that mean, because that works out that interval, that gap, and I subtract that off. So if I go back to our calculator, we're going to have 56 minus that number we just got, minus 56, whoops, and execute, and we get our lower limit of 31.176, so 30.176. And so now I can write that as a confidence interval. So there we go. If we want a confidence interval for the standard normal, we got to work out our proportion using 0.5 plus or minus c over 2, and we can use either the plus or the minus, whichever one. It'll give us the corresponding, either the upper or the lower, and we've just got to write down the opposite, which is the plus or the minus respectively. If I've got a normal variable with a different mean and standard deviation, I can either work out my z-score and then add or subtract that from my z-score times my standard deviation off of my mean, and it'll give me my confidence interval. Or if I put in my mean and standard deviation into our inverse normal, I can get my upper or my lower if I use the lower version when I was trying to use the subtract version when working out my proportion. And then I've just got to work out my opposite.